Welcome back. We have seen the commutative law of addition and commutative law of multiplication in the last lecture. So a plus b is equal to b plus a. That means if the order in which the variables are odd makes no difference. So addition, addition is commutative. So a plus b is equivalent to b plus a, and this can be shown by taking these two variables a and b. Similarly, the commutative law of multiplication is there. So the order in which the variables are ANDed makes no difference. So if this is the multiplication of two variables a and b, and if the order of a and b is changed, it makes no difference. So the order in which the variables are ANDed, because AND gate has the operation of multiplication. So therefore it is called as the ANDed, makes no difference. Now let us move to the next law, that is called as the associative law. So this law states that ORing more than two variables, when we add more than two variables, so a, b, c suppose, so ORing more than two variables, the result is same regardless of the grouping of the variables. So if you are using the variables more than two variables, and you group these variables as you wish, but the final result will be same. So ORing means addition. ORing more than two variables, the result is same regardless of the grouping of the variables. So it does not depend upon the grouping of the variables. Suppose in this equation a plus b plus c, so b plus c is taken in the bracket and is equal to a plus b plus c. So here first b plus c, they are grouped together and then they are added to the a. So the variable a is separate, but b and c are grouped. Now this order of the grouping is changed to the right hand side. So here the grouping of a plus b. So grouping of two variables a plus b is done here, and to this a plus b we have added the third variable c. So this group the ORing. So how you group the variables, it does not make any difference on the addition of the variables. So a plus b plus c is equal to a plus b plus c. So here b plus c are grouped and here a plus b are grouped together. So ORing more than two variables, the result is same regardless of the grouping of the variables. So we can verify these equations, left equation as well as right equation, by applying some OR gate. Now take this b plus c. So this lower AND gate adds two variables b plus c, and the output of this b plus c is added to the a. So here the output of this b plus c OR gate is the input of the first OR gate, and therefore this is a, and this is this input is b plus c. So this is output is a plus b plus c. Now in the second circuit, the grouping order is changed. So a plus b are grouped. So the first OR gate has the inputs a plus b. They produces the output a plus b, and this output is applied to the second OR gate. So this is a plus b plus c. So this is the input is c, and this is input is a plus b. So the output is a plus b plus c. So both these circuits will function in the same manner. The outputs of both the circuits are same. So result is same, though we have changed the order of grouping. Now this is the associative law of addition. Similarly, we have a associative law of multiplication. So associative law of multiplication, the order in which the variables are ANDed makes no difference. Again the same statement, only the variables are ANDed here. जर आपण AND ऑपरेशन केले या व्हेरिएबलची, तर आपण ही ऑर्डर जी ग्रुपिंगची ऑर्डर जी वी कॅन चेंज दॅट ऑर्डर. तिथे आपण काय केलं, व्हॉट वी डीड हियर, वी ग्रुपड बी अँड सी. या ठिकाणी आपण बी आणि सी ची ग्रुप केलं आणि इट इज देन ANDed with a. Now in the right hand side we grouped a and b and ANDed it with the variable c. So both the so a dot b dot c is equal to a dot b dot c. So this side, left hand side, is equal to right hand side. If you verify, this is by AND gate, because this multiplication is done by the AND gate. So this is B dot C. So first this is AND gate 1, this is AND gate 2. So input to the AND gate 2 is B and C. So the output will be B dot C. This becomes ANDed with A. So again this B dot C is the input to the first AND gate, and this is the A input. So this will give the A dot B dot C. Now here B dot C are grouped. Now similarly, if you change the grouping order, so group A and B, two variables A and B are grouped. So they are applied to the first AND gate. So the output will produce A dot B, A dot B, here A and B, and this output is applied to the second AND gate, and the third variable C is usually here. So A dot B in the bracket dot C. So this is the output of this right hand circuit. So the result will be same, though we have changed the order of variables when they are ANDed. So therefore, the this is the variables follows the associative law of multiplication. So this is called as the associative law of multiplication. This is the associative law of addition, right? Then distributive law. Distributive law. This is the third law, which is used in the Boolean algebra. So ORing two or more variables, and then ANDing the result is equivalent to ANDing the single variable with each of the two or more variables and then ORing the product. So what does it mean? Suppose that this is the A dot B cross C. Right? So ORing two variables. So इथे आपण काय केलं, A B plus C, they are ORed together. आपण यांचं काय केलं आपण या ठिकाणी we have performed the OR operation, ORing. ORing two variables or more variables and then ANDing the result. So then B plus C is ANDed with A. B plus C is ANDed with A. So this is equivalent to ANDing the single variable with each of the two or more variables. So here the other variables are B and C. So AND this A with B and AND this A with C and then add these variables. So या ठिकाणी आपण A चं ANDing B C करणार आणि A चं ANDing C C पण करणार आणि हे दोघं आपण काय करणार, ऍड करणार. So is equivalent to ANDing the single variable with each of the two or more variables and then ORing the product. या ठिकाणी आपण हा जो प्रॉडक्ट A डॉट बी आणि A डॉट सी याचा आपण पुन्हा काय केलं, आपण OR केला, OR ऑपरेशन. वी परफॉर्म द OR ऑपरेशन, राइट. सो A डॉट बी प्लस सी इज इक्वल टू A डॉट बी प्लस A डॉट सी. जर अशी सिच्युएशन येत असेल तर दॅट इज कॉल्ड एज द डिस्ट्रीब्युटिव्ह लॉ. दिस इज द डिस्ट्रीब्युटिव्ह लॉ. Now this law can be easily verified using in the left hand side. Use the OR gate because B plus C is the OR operation. So we must have to use the OR gate, and A dot B plus C. So we must have to use the AND gate. So so this OR gate will give the B plus C, and this B plus C is ANDed with A. So this is A and AND gate, and it will produce A dot B plus C. So this is the circuit for left hand side, equation in the left hand side. Now make the circuit for right hand side, because both these are same. The result will be same for both this left hand side as well as for right hand side. Now A dot B. So the two variables are ANDed. So this is one variable A and B. So these two variables A and B, they are ANDed, and now because A and dot B, therefore we use this AND gate. Now the second is also AND gate. So A dot C. Now take the A and C. So they are ANDed, and then these two outputs A dot B and A dot C. So output of AND gate 1 and this is output of AND gate 2. They are ORed. त्यांचं आपण काय केलं, आपण OR operation केलं, and therefore use the OR gate. So we use the OR gate, and the final output will be A dot B plus A dot C. So this is these are the very simple rules for Boolean algebra. So this is the distributive law. This is called as the distributive law. So using these laws and De Morgan's theorem, so commutative law of addition, commutative law of multiplication, and associative law of addition, associative law of multiplication, and distributive law, this Boolean algebra has made some rules or theorems, and these are the basic theorems in the Boolean algebra. These are the variables A and B. These are the variables, and their operation is shown in this table. So let us take the first variable A plus 0 is equal to A. So these are the, suppose A plus 0 is equal to A. So this is the one rule of Boolean algebra, or one theorem, A plus 0 is equal to A. That means if you add 0 to any variable, if you add 0 to any variable, then the output will be the variable itself. Output will be the variable itself. Now, for example, if you add 0 to 5, the output will be 5. If you add 0 to 3, the output will be 3. So A plus 0 is equal to A. That means whatever you have the variable, if you try to add 0 to it, the variable will not change. So it is A plus 0 is equal to A. The value will be A. Now take second theorem, A dot 1 is equal to A. A dot 1 is equal to A. So what does it mean? Now you know, in case of multiplication, if you multiply any number by 1, the number will not change. Suppose 5 multiplied by 1, it is 5. 10 multiplied by 1, it is 10. 15 multiplied by 1, it is 15. So multiplying the variable with 1 does not change its value. Multiplying the variable with 1 does not change its value, and therefore this is the second theorem. So A dot 1 is equal to A. So multiplying A with A does not change the value of variable A. Then the third theorem is A plus 1 is equal to 1. A plus 1 is equal to 1. So what does it mean? That means if you add 1, to any variable, if you add 1 to any variable, or if you make a OR operation with any variable, keeping one variable as 1, then the output is always 1. Then the output is always 1. Now here in this equation, if A is equal to 0, if put here A is equal to 0. So 0 plus 1 is 1. 0 plus 1 is 1. Now if you put 1, so 1 plus 1, the OR operation will produce one output. The OR operation will produce one output. So 1 plus 1 is also 1. So adding 1 into any variable makes the variable value 1. Makes the variable value 1. So it does not changes. Now the next rule is A dot 0 is equal to 0. Again it is very simple. If you multiply any variable with a 0, the result will be 0. If you multiply any variable with 0, the result will be 0. Multiply 5 by 0, output is 0. Multiply 10 by 0, the result will be 0. So if you multiply any variable with 0, the result will be 0. This is the next theorem. So in this way, we can have the number of theorems here, and using these theorems, nearly there are 22 theorems. You remember all these theorems. So these theorems are very useful in simplifying the digital electronics, the circuits. So they are very useful in solving the Boolean algebraic equation. So from these theorems, we have some Boolean relations about the OR operation, as well as Boolean relation for AND operation, and double inversion rule or duality theorem. So we can have the conclusions from this truth table. So from this truth table, so these are the Boolean relation about the OR operation. Now in the OR operation, suppose in OR operation, suppose you take 2-bit addition. So this is A plus 0, it will produces the A. So this says that variable odd any variable or with the 0 equals the variable. म्हणजे कुठलाही आपण व्हेरिएबल घेतला आणि त्याची जर आपण ऑर ऑपरेशन घेतली तर व्हेरिएबल काय मिळेल तुम्हाला, जे इनपुटला असेल तेच आपल्याला आउटपुटला मिळेल. So the variable odd with 0 equals the variable. If input variable is a, समजा आपण इनपुट व्हेरिएबल 1 घेतला तर आउटपुटला काय मिळेल आपल्याला 1 मिळेल. इफ इनपुट व्हेरिएबल इज 0, आउटपुटला काय मिळेल आपल्याला 0 मिळेल. So if a is 0, then output is 0 and b is and if a is 1, the output is 1. So when we ORed the variable with 0, it produces the variable itself. Then this is the second theorem, a plus a is equal to a. So a variable ORed with itself, variable ORed with itself म्हणजे त्याचंच आपण OR ऑपरेशन घेतलं, is equals the variable, म्हणजे आपल्याला पुन्हा तोच व्हेरिएबल मिळतो. म्हणजे 1 plus 1 you will produce the 1, 0 plus 0 will produce the 0. So 1 plus 1 म्हणजे thus we say that variable ORed with itself is equals the variable. If a is 0, then 0 plus 0 is 0, and if a is 1, then 1 plus 1 is also 1. So the variable will appear as it is in the output. Now the third relation is a plus 1 is equal to 1. That means if we variable is odd with 1, if the variable is odd with 1, it always equals to 1. The output is always equals to 1 regardless of the value of the variable. So here whatever the value of the variable a, the output will be 1. Suppose the value of a is 1, so according to this a 1 plus 1 is 1, and if the value of a is 0, then 0 plus 1 is again 1. So this says that variable odd with 1 is always equal to 1. आपण जर त्या व्हेरिएबल मध्ये आपण प्लस 1 ऍड करत असून तर व्हेरिएबलची व्हॅल्यू आपल्याला इटसेल्फ मिळते. किंवा आपण इफ a is 0, then 0 plus 1 is 1, and if a is 1, then 1 plus 1 is 1. Now the fourth theorem is a plus a is equal to 1. A plus a is equal to 1. This says that a variable odd with its complement is always equal to 1. So here the statement is written somewhat wrongly. So here this is the statement is a plus a complement. A plus a complement means OR operation of the variable and its complement. OR operation of variable with its complement. म्हणजे आता आपण समजा व्हेरिएबलची व्हॅल्यू आपण 0 घेतली, समजा व्हेरिएबलची व्हॅल्यू आपण 0 घेतली तर त्याची कॉम्प्लिमेंट काय असतो 1, म्हणजे 0 प्लस 1 आउटपुट काय मिळेल आपल्याला 1 मिळेल. आणि समजा आपण व्हेरिएबलची व्हॅल्यू 1 घेतली तर आपल्याला 1 प्लस 0 पण पुन्हा आपल्याला काय मिळेल 1च मिळेल. सो इट सेज दॅट व्हेरिएबल ऑड विथ इट्स कॉम्प्लिमेंट, म्हणजे हा व्हेरिएबल आहे आणि त्याचं आपण ऑर ऑपरेशन विथ त्याचा कॉम्प्लिमेंट जर आपण केली तर रिझल्ट काय मिळेल आपल्याला ऑलवेज द रिझल्ट इज ऑलवेज 1. सो इफ द व्हेरिएबल इज ऑड विथ इट्स कॉम्प्लिमेंट it gives the value equal to 1. It gives the value equal to 1. आता इथे आपण समजा if a is equal to 1, a is equal to 0, if a is equal to 1, त्यानंतर आपल्याला a कॉम्प्लिमेंट काय मिळेल 0 मिळेल. So 1 plus 0 is 1. If a is 0, its complement is 1, then 1 plus 1 is 1. So these are the rules for Boolean relation about these are the various Boolean relations about OR gate. Now similar Boolean relations can be studied for the AND gate. Now in the AND gate, if one of the input is kept high, then the output will be the variable itself. The output will be the variable itself. So this says that variable ANDed with 1, variable ANDed with 1. So this is a is the variable, it is ANDed with 1. So it is always results in a value of the variable itself. It results in a value of the variable itself. जे आपण हा a जो घेतलेला आहे त्याच्यामध्ये काही चेंज होणार नाही. सपोज a is equal to 0, then 0.1 is 0. If a is equal to 1, 1.1 is 1. So that means the a will appear at the output. Right. Now the second theorem is A dot A is equal to A. So this says that variable ANDed with itself. समजा आपण तोच variable दोघं इनपुट्सला अप्लाय केला तर आउटपुटला काय मिळेल आपल्याला, that variable itself. So this says that variable ANDed with itself is equal to the variable. म्हणजे आपण त्या व्हेरिएबलचं त्याच्याशीच आपण AND ऑपरेशन केलं तर आपल्याला काय मिळेल, आउटपुटला तोच व्हेरिएबल मिळेल. सो हियर इफ A is equal to 0, जर आपण A is equal to 0 घेतला तर 0 into 0 it is 0. जर आपण A is equal to 1 घेतला तर 1 into 1 is 1. सो म्हणजे आपल्याला A जो घेतला आपण तोच आउटपुटला मिळतोय. नाउ दिस थर्ड प्रॉपर्टी रिलेशन इज व्हेरी इम्पॉर्टंट. A dot 0 is equal to 0. That means if the variable is ANDed, with 0, the result is always 0. The result is always 0. म्हणजे जर आपण AND गेटचं एक जरी इनपुट 0 असेल तरी सुद्धा आउटपुट काय मिळेल आपल्याला, 0 मिळेल, वॉट एव्हर द अदर इनपुट्स आर. कारण बिकॉज A डॉट 0 इज 0, म्हणजे A ची व्हॅल्यू तुम्ही काय 0 घ्या 0, 1 घ्या 0, बरोबर. So whatever the value of A, the output will be 0. So this says that variable ANDed with 0 is always equal to 0. If A is equal to 1, तर आपल्याला आउटपुट मिळेल 0, आणि if A is equal to 0, the output पण काय मिळेल आपल्याला 0. So this is the third rule associated with the Boolean relation, or this is the third Boolean relation. Now double inversion rule is complement of complement is equal to variable itself. Complement of complement is equal to variable itself. Now this is, suppose this is the variable is A. Now its complement is A complement, right? So A complement means inverse the digit. Change the digit from 0 to 1 or 1 to 0. म्हणजे जो डिजिट असेल त्याचा अपोजिट करणं म्हणजे काय, that is the complement, बरोबर. So this rule says that the double inversion, किंवा त्याला आपण complement of a variable equals the variable itself, बरोबर. तर आपल्याकडे व्हेरिएबल A आहे समजा, बरोबर, त्याचा कॉम्प्लिमेंट A कॉम्प्लिमेंट, आणि पुन्हा त्याचा कॉम्प्लिमेंट म्हणजे A कॉम्प्लिमेंट ऑफ कॉम्प्लिमेंट, A कॉम्प्लिमेंट ऑफ कॉम्प्लिमेंट जर आपण म्हणजे घेतला तर इट विल कम टू बी A, बरोबर. समजा आपण A इज इक्वल टू 0 घेतला, त्याचा कॉम्प्लिमेंट 1, फर्स्ट कॉम्प्लिमेंट काय आला 1, आणि 1 चा परत कॉम्प्लिमेंट 0, बरोबर. म्हणजे कॉम्प्लिमेंट ऑफ कॉम्प्लिमेंट इज द व्हेरिएबल इटसेल्फ. कॉम्प्लिमेंट ऑफ द कॉम्प्लिमेंट इज इक्वल टू द व्हेरिएबल itself. So this is the double inversion rule. Complement of complement is equal A complement of complement, double complement त्या ठिकाणी थोडक्यात म्हणूया आपण डबल कॉम्प्लिमेंट. सर जर आपण एखाद्या व्हेरिएबलचा डबल कॉम्प्लिमेंट घेतला तर तो काय दाखवतो आपल्याला, तो व्हेरिएबल ऍज इट इज दाखवतो. सो वी गेट द सेम व्हेरिएबल. नाउ द लास्ट theorem is the duality theorem. So what is the duality theorem? What it states, म्हणजे हे जे OR ऑपरेशन आहे बघा, A plus 0 is equal to A. So addition of 0 किंवा OR operation with variable, each OR operation by AND. So A plus 0 is equal to A, and the dual relation is A dot 1 is equal to A. Right. म्हणजे आपण समजा OR operation is when the OR operation is done with 0, when OR operation of any variable, is done with 0, then the output will be the variable itself. And if the if the AND operation is done with 1, then the variable is again does not change. So A plus 0 is equal to A, or A dot 1 is equal to A. That means if any one input of this variable is 0, the output is the variable itself. आणि या ठिकाणी कुठलाही व्हेरिएबल आपण 1 ने मल्टिप्लाय केलं तर इट विल नॉट चेंज द व्हॅल्यू ऑफ द व्हेरिएबल. तर याला म्हणतात ड्युअलिटी थेरम. सो चेंजिंग ईच ऑर ऑपरेशन बाय अँड, म्हणजे आपण हे इक्वेशन आणि हे इक्वेशन या दोघांचं आउटपुट काय सारखं आहे, फक्त इकडे कुठले ऑपरेशन आहे, अँड ऑपरेशन आहे, सॉरी आर ऑपरेशन आहे, आणि इकडे कोणते ऑपरेशन आहे, अँड ऑपरेशन आहे बरोबर. म्हणजे ऑर ऑपरेशन जर आपण चेंज केली अँड मध्ये तरी रिझल्ट आपल्याला काय मिळेल, सेम मिळेल. सो चेंजिंग ईच ऑर ऑपरेशन बाय अँड ऑपरेशन किंवा आपण चेंजिंग ईच अँड ऑपरेशन बाय ऑर ऑपरेशन, आपण प्रत्येक अँड ऑपरेशन आपण ऑर ने रिप्लेस करू शकतो. सो कॉम्प्लिमेंटिंग एनी 0 or 1 appearing in the expressions. सो कुठलाही जो 0 असेल किंवा 1 असेल त्याला आपण कॉम्प्लिमेंट करून त्याला आपण एक्सप्रेशन तयार करू शकतो. सो दीज आर दी ड्युअलिटी थेरम्स. These are the duality theorems. A plus 0 is equal to A and A dot 1 is equal to A. So these rules or theorems are very useful. These rules or theorems are very useful for simplifying the logical expressions or Boolean expressions. So this is the simplification of different Boolean equations. So consider the NAND operation of three variables A, B and C. A, B and C यांची आपल्याला NAND ऑपरेशन बघायची आहे. आपल्याला माहिती आहे NAND आउटपुट काय असतं, A डॉट B डॉट C कॉम्प्लिमेंट, कारण NAND मीन्स नॉट अँड बरोबर. सो A डॉट B डॉट C विल गिव द अँड ऑपरेशन अँड इट्स कॉम्प्लिमेंट गिव्स द NAND ऑपरेशन. सो A डॉट B डॉट C त्याचा आपण काय घेतला, आपण कॉम्प्लिमेंट घेतला बरोबर. सो दिस इज द NAND ऑपरेशन. दिस इज द NAND ऑपरेशन. आता आपल्याला हे ऑपरेशन आपल्याला सिंपल करायचंय. काय करायचं आपल्याला, सिंपल करायचंय. मग आपण काय केलं, लेट अस ग्रुप ए अँड बी. आपण ए आणि बी चा ग्रुप करून घेतला, ए अँड बी आणि डॉट सी. आपल्याला माहिती आहे की अकॉर्डिंग टू द रूल दिस इज द लॉ ऑफ डिस्ट्रीब्यूशन. दिस इज द लॉ ऑफ डिस्ट्रीब्यूशन. सो ए डॉट बी डॉट सी. नाउ अप्लाय हियर द डी मॉर्गन्स फर्स्ट theorem. Sorry, De Morgan's second theorem. What is the De Morgan's second theorem? Product of the complement is equal to sum of the complements. Product of the complement is equal to sum of the complements. आता आपण A dot B ला एक व्हेरिएबल गृहीत धरा. A dot B is the one variable and dot C is the another variable. समजा आपण याला x म्हटला आणि याला c म्हटला. So this A dot B is x. So x dot c. Now x dot c complement, it is the complement of the product. It is the complement of the product. Now complement of the product can be converted into sum of the complements. Sum of the complements. Now suppose A dot B is x, so this is x complement plus c complement. But value of x is A dot B, so this is A dot B complement plus c complement. So using the De Morgan's second theorem. Now again this A dot B complement can be simplified. So apply here again the De Morgan's second theorem. So complement of the product is equal to sum of the complements. So replace this product by sum. So this is A complement plus B complement, and therefore and plus this C complement. So the final equation will be A complement plus B complement plus C complement. So so A dot B dot C complement is equivalent to A complement plus B complement plus C complement. So what does it mean? So the product of the complement is equal to sum of the complements. Product of the complement is equal to sum of the complements. So A dot B dot C complement is equal to A complement plus B complement plus C complement. So this is the this is using the NAND gate. So now similarly the NOR operation of the three variables. तर आपण NOR ऑपरेशन आपण ही NAND ऑपरेशन आपण घेतली. आता आपण OR ऑपरेशन घेऊया. कुठली, NOR नॉट OR बरोबर. NORचं एक्सप्रेशन काय येईल, A plus B plus C complement. So this is the three variable three input OR gate. This is three input NOR gate. The output of the three input NOR gate is A plus B plus C complement. Now simplify again this using the De Morgan's theorem. So according to आता पहिल्यांदा काय केलं, A plus B चा एक ग्रुप करून घेतला plus C. A plus B plus C. So this is according to our law. Now this is पहिल्यांदा आपण याचं सॉल्व करून घ्या. A plus B म्हणजे sum of the complements is equal to product of the complements. Sum of the complements is equal to product of the complement. So this is a plus b complement dot c complement. A plus b complement dot c complement. Now this again a dot b complement में क्या a complement dot b complement. So again this is a complement dot b complement dot c complement. So a plus b plus c complement is equivalent to a complement dot b complement dot c complement. So using the De Morgan's theorem, we can simplify these equations. Sum of product form of the equation. The sum of product form म्हणजे काय? So sum of product. So if there are 4 variables, take the 4 variables a b c d. समजा आपण हा a b c d 4 variables दिले, त्यांचा काय घेतला आपण product plus याच्याला एक variable आपण. So this equation when this equation will produce the output 1, output 1, so that ones can be obtained by this expression, and therefore this expression is called as the sum of product form. So पहिल्यांदा काय करा, b चा कॉम्प्लिमेंट करा, नंतर a c d तसंच ठेवा, नंतर a चा कॉम्प्लिमेंट करा, b c d तसंच ठेवा, प्लस a b बार c बार d आणि product of sum. So this is sum of product and this is product of sum. So आता a plus b plus c, a plus b complement plus c, a plus b complement plus c complement, या काय झालं, these are the sums. आणि या समचा product बरोबर, तो आपल्याला काय मिळेल, y मिळेल. इथे product of the sum of products आहे, हे जे products आहेत a b c d, a dot b dot c plus a b c d, a complement b c d, तर हे या प्रॉडक्टची आपण नंतर काय घेतोय, सम घेतोय, आणि इथे सम ची आपण काय घेतोय, प्रॉडक्ट घेतोय. सो दिस इज कॉल्ड एज सम ऑफ प्रॉडक्ट फॉर्म अँड दिस इज कॉल्ड एज द प्रॉडक्ट ऑफ सम फॉर्म. पहिल्यांदा आपण म्हणजे प्रॉडक्ट कोणाचा घेतोय, आपण समचा प्रॉडक्ट घेतोय. प्रॉडक्ट कशाचा घेतोय, समचा प्रॉडक्ट घेतोय. या ठिकाणी आपण सम कशाची घेतोय, प्रॉडक्टची घेतोय. सम कशाची घेतोय, प्रॉडक्टची, म्हणून याला सम ऑफ प्रॉडक्ट फॉर्म म्हणतात. आणि याला काय म्हणतात, product of sum form. The fundamental products के त्याला आपण minimum values आपल्याला कशा मिळतील, that is not important here. So this is all about our syllabus. If you have any doubt, you can raise your hands. But I think I have covered almost all these things, and so this was our 30th lecture of the SIBSE syllabus. Now we have completed our syllabus as per the university norms. If you have any doubt, or if some topic is left by me due to oversight, you may bring to my notice. I will try to cover that topic later on, or whenever the time permits. But now till now our syllabus is complete. I wish you best of luck for your examination. Thank you.